tonight, by the way, so you'll be ready for this. Okay, so I am recording now. Whoops. And last day, excuse me, we talked about kinetic molecular theory, and we did a little brief introduction on this section. The section is about the octet rule, but more specifically, we did a little review of the first two topics. We didn't really do anything else. So just a reminder for you guys to get started or to understand what I'm doing today. Group 1A has 1 electron, 2A has 2 electrons. This we would call on the periodic table 13, 14, 15, 16, 17, 18, and they have the number of electrons after the number 1. Okay, then again, we did this last class, so you guys should be okay with this. We did this question, so nitrogen is in group 15, 5 electrons. Neon is in group 18, 8 electrons. Hydrogen is in group 1, 1 electron, and carbon is in 14. Again, we did this yesterday, and we did this also in unit 1. So I think we're ready to get into the next topic. The next topic is extremely important for this course. Anybody moving into chemistry 1121, that would be chemistry 2, or anybody especially moving into chemistry 3, where it's about organic or hydrocarbon chemistry. So all I want to do today, and this won't take me very long, because again, you guys are ahead of the other class, is I want to show you how to draw what's called an electron dot diagram. Now, one thing, electron dot diagrams, these are also called Lewis dot diagrams. And the only reason I'm telling you that is because if you go online and you want to do some practice, or maybe you have an old chemistry book lying around, most first year, even high school chemistry books, if you have them, you don't need one, but they might call this Lewis. That's obviously somebody's name, but we tend to just call them electron dot diagrams. And it's exactly what it sounds like. It is a diagram that shows electrons as dots, little periods you could call them, or little decimals around the atom. So an electron dot diagram shows an atom's valence electrons. This is important. Only shows the valence. So there's 2 terms I want you guys to know before I move forward. And I guess not terms, but 2 words or phrases that you need to know before moving on. First one is lone pairs. Now that word sounds a little weird, or the phrase sounds a little weird. What is a lonely pair? Well, it's not necessarily lonely, it's just called in chemistry a lone pair. These are grouped electrons in groups of 2. Okay, that means a pair. So, if you had a pair of shoes, a pair of socks, that is, I don't see a lot of people wearing socks here. I don't think I've ever spent a day in my life without wearing socks. But anyways, a pair of shoes or something, it means 2. So these are electrons that are not involved. And what I mean is they don't take part, they're not used in bonding. And this unit is all about bonding and naming. It's a pretty long unit, I must say. So when I talk about bonding, I mean when 2 elements get together to form a compound, that's a bond. There's different types of bonds, but we'll get into that later. So speaking of bonds, this guy on the left, this little lonely dot, he doesn't have a pair. He has no partner, right? You can think about in the lab, this guy would have no lab partner. This is a bonding electron, and these are involved. They do take part in bonding, and I'm going to show you an example, I think, very shortly. Okay, now those terms we will talk about in greater detail later. I know I keep saying that, don't I? We'll talk about this later. We'll talk about this later. But that's the way the first year chemistry works. Like I introduce little tiny topics, and then we start to put them together. It's like math. You know, you learn to add and subtract and multiply, and the next thing you know, you're doing algebra and square roots and calculus. So it's kind of how chemistry works. So the method to draw these, let me go step by step here. It's very simple. My class this morning had a little bit of confusion, and I was surprised because they're very strong students, just like you, but there was a little confusion. So I'll go extra slow through this slide. The first thing you do is write the element symbol. Now, we in Chemistry 1120, we're only going to be dealing with group A. So that would be group 1 and 2, and then 3, 4, 5, 6, and 7. So we're sticking with group A here. The transition metals, we really can't do electron dot diagrams. So we're sticking with group A. So you write the chemical symbol. Now, before I even get to the next part, I want you to imagine fluorine, that's F, that's fluorine, as having a little box around it. And on the, like with a box or a square, a rectangle, I guess I should say, we have a top, we have a right side, we have a bottom side, and we have a left side. If any of you guys play video games or are interested in maps, obviously you don't need to know either, but I mean, if you've ever heard of north, east, south, west, these are called like a Cartesian plane. People use them in map making. I play a lot of video games, so if you're walking around in a video game, it might say your objective is northwest. So I'm familiar with these coordinates. If you're not familiar, just think of a box, and I'll explain what the box represents in a minute. So after you've written the element symbol, you then need to figure out how many valence electrons it has. Fluorine has 7 electrons because it's in group 17. Okay, so I'm going to need to draw at least 7 dots around this F. And when I draw them north, east, south, west, or top, right side, bottom side, left side. And I go clockwise. So I'm going clockwise around each side of the atom. If you're not familiar with clockwise, it's in this direction. Okay, the way, I know most people these days, we don't use old clocks with the hands, but an old clock would go from like say, top 12 o'clock towards the right. So it kind of spins towards the right and around. I had a student in the other class ask, does it really matter? And it kind of doesn't. Really, the big thing that matters. Oops, sorry guys. Hold on 1 second. Okay, the lion is back. I'm sorry about that. Anyways, this is this little note on the bottom here is the big one. Again, this student in the other class, Kevin is his name. He said, do I have to start from the top? Do I have to go clockwise? Between us and YouTube, it honestly doesn't matter. But what does matter is that you go 1 electron at a time on each side. And then if you have more than 4, because there's 4 sides, you then start to pair them. So guys, just look what's going to happen to fluorine on the bottom here. And again, imagine fluorine has an invisible box around it. Okay, and just watch what happens. So 1 electron out of 7, 2, 3 on the bottom, 4 on the left. And now every side of that box has an electron. So I have an electron north, east, south, and west. Top, right side, bottom side, left side. I still have 3 electrons though. Remember, I don't know if you guys are following along too closely, but fluorine has 7. So I still have 3 left. So look at where the 5th one goes. I start over at the top. So 5. Now I continue going 6, 7. And there it is. That is my electron dot diagram. Now you guys might wonder, sorry, my dog won't be too crazy. You guys might wonder, what is the point of this? Like, I mean, what does this have to do with anything? And the answer is everything with bonding. So let me just define these electrons for you again. These 3 groups here, we call these lone pairs. They have nothing to do with bonding. But look at this guy. He's special over there on the right side, left side, sorry. He's a bonding electron. And he's very special. The bonding electron is going to it tells me that fluorine forms 1 bond. And again, if this makes no sense, just watch the next slide. And I think I'm gonna explain something really cool to you. Well, actually, sorry, on this slide, I'll explain something really cool to you about how this works. But anyways, drawing this electron dot diagram tells me that fluorine has 1 bonding electron, and it's probably going to form 1 bond, a single bond, we call it. It also tells me how this will form an ion, and I won't get to that today because I didn't get to that with my other class. But this empty space here where there could be 1 more electron tells me something special about the fluorine ion. Okay, so here, guys, my plan for today, it's only 10 to 4. I want to show you 3 examples. I'm going to ask you guys to do 3 examples. And then the only thing I did with the other class is I got to this sodium octet rule, and then that was it. So we're not looking at a very long class today. Now, before I do these examples, let me check the chat here. Ooh, I got a question. I'll answer that question. Well, I know I can answer that aloud. It might be on YouTube. But the question was, what games am I playing? And I don't mind answering that. What am I playing? I'm still playing a little bit of Animal Crossing. There's a game, No Man's Sky on PlayStation I've been playing. And I've been playing Fall Guys as well. Or trying to play Fall Guys. I can't get into the server very much. So anyways, between those 3 games, that's what I've been playing lately. I could talk about games and maybe after class if anybody has questions, because I play way too many video games. But anyways, let me get back into this. Okay, so I'm gonna do 3. You guys do 3, and then I got 1 more little topic to do. And yeah, I mean, someone in the chat just said they love Fall Guys. I love it. But I can't get connected to a match very much. I keep like waiting in the lobby for a match. Anyways, the first time I played Fall Guys, I came in basically 2nd place. And I still haven't won. Someday I'll win. Anyways, okay. So step number 1, you cannot do this question if you don't know the group number or you don't know the number of valence electrons. Now, for anybody who really can't remember or hasn't been paying attention, the group number is straight from the periodic table. So look at the column up and down that the chemical is in, and literally at the top of the periodic table, it will tell you the group number. If any of you have problems finding group number, let me know. But it's straight from the periodic table. It is the number at the very top of the table. So I know magnesium is in group 2. Whoops, my bad. Aluminum, or aluminium, as the British people say, is in group 13, and phosphorus is in 15. Now, I made my life a little easy. I gave myself the easy ones. You guys get the hard ones, but anyways, that's it. So easy, right? Okay, step number 1. Well, okay, I mean, arguably step number 1 is to just make a note that this has 2 electrons because it's in group 2. So I draw magnesium. I picture an imaginary box around this element, and I start at the top and I go 1 electron, sorry. 2 electrons, I am done, that's it. This is magnesium. Now, this tells me a couple things. Using this information of the electron dot diagrams, I can tell that magnesium might form 2 bonds. I can tell that magnesium might be a 2+ cation. Like, there's a lot of things that we'll learn from this as we go through chapter 3. Okay, let me pick another color. I'm going to do aluminum. Aluminum is really easy. It's basically the same thing, 3 electrons. So Al is aluminum. 1, 2, 3. Now remember what I'm doing. I'm starting at the top, putting an electron there. I move to the right side of the box, another electron. I move to the bottom of the box, another electron. Or again, if you're familiar with maps, or like I said earlier, video games, I put one on the north, on the east, on the south. Okay, this is a better one. I think you'll get the idea a little more with phosphorus. So let me pick a new color. We'll go purple. Phosphorus has 5 electrons. So P. I get a lot of students sometimes get confused with potassium and phosphorus. Potassium is K, phosphorus is P. Okay, I used to know the answer to this. Why is potassium K? Okay, well, interesting. Yeah, it comes from Latin, maybe arguably Arabic. The origin isn't that clear, but they say potassium is called K because it comes from the Latin kalium, Kalium. So anyways, phosphorus, luckily for us, is P. All right, electron on the top, north, so I go 1, and I go to the east side. I'm going clockwise, south, oops, and then west, or the left side. Now I have every side of the imaginary box filled. I still have 1 more electron to fill, so I go back to the top and I start over, okay? This one is more like what you'll see on the next slide. I gave you guys harder ones to practice. Just a reminder, and then I'm gonna give you guys 2 minutes to practice this. This is called a lone pair. It is not involved in bonding. And these 3 guys are called bonding electrons. So I could assume that if phosphorus formed a compound, it would probably have 3 bonds. Okay, I'm going to put myself on pause. I am going to also pause the recording, and I will be back in 2 minutes. Now, I know you guys can't really, you can draw on the screen. If anybody wants to try to draw these on the screen, you can. I'll kind of step away and let you guys do what you want. But you can also talk about it in the chat. I know you can't draw this in the chat. What I really want you to do is maybe take a pen or a piece of paper that you have in front of you, I hope you do, and just try the 3 of these. Now, if any of you do not have your periodic table, I'm willing to help you. Argon is in group 18, chlorine is in 17, and hydrogen is in 1. Ooh, somebody's drawing there. Okay, I'm going to pause myself. I'll be back in 2 minutes. And whoever just drew hydrogen is perfect. I'll be right back. Don't forget your L in chlorine. Chlorine is Cl. Cool. I mean, this is 10 out of 10. If this was like a little messy, but you're obviously drawing with your probably finger or mouse or something. I don't know what you're using. Someone's going to put a heart there. It looks like, yeah. Okay, perfect. No, this is 10 out of 10. So what I'll do when you guys are done drawing, I will, I'm just going to quickly show you or explain to you how technically I would do it. But guys, everything I'm seeing here is perfect. Even if someone's drawing that chlorine now, it's beautiful. Okay, so if you guys don't mind, I will clear your drawings, not to be rude because they are perfect. But I just want to show you my kind of, for anybody who doesn't get it yet, I will show you. Okay, so, oops, I'm just going to, there we go. Okay. All right. Sorry. Just to avoid messiness, I disabled drawing. We're almost done for today anyways. And the only reason I'm doing this again is I do want to show you something that's kind of interesting. So the student or students who did argon, it was beautiful. I saw a lot of students like doing 2 dots at once. Be very careful doing that. Now, honestly, some of you probably knew what you were doing and just decided to fill it in as quick as possible. But the method here is, because argon has 8 electrons, I would go 1, 2, 3, 4, 5, 6, 7, 8. Okay, chlorine, and I'm gonna go quick because you guys had the answers. 7 electrons, so chlorine looks just like fluorine. I'm gonna do something. I'm gonna move chlorine over because I wanna show you something. Okay, so there's my chlorine, and then hydrogen, the easiest of all elements because it's just 1 electron. Okay, so there's a lot I can actually say about this slide, a lot. First thing I want to mention is look at argon. Argon has no bonding electrons. It's all lone pairs, not peers, pairs. Think about that. I told you guys in chapter 2 that noble gases, the elements in group 18, do not like to bond with anything. Well, now there's no wonder why they don't like to bond. There's no bonding electrons. They're all paired up. So think about if you were in the lab and you all had lab partners and then someone else comes in. Well, we can't have a group of 3. You all have partners. You're not going to, accept that person into your group because you can't. It's only 2 people per group. Okay, now the other thing I want to show you, and this is getting a little bit advanced, but it's really interesting to know. I'm kind of running out of colors here. I'll go light blue. There is a chemical you've all probably heard of. It's in your stomach right now. It's hydrochloric acid. Okay, one of the strongest acids. There's 6 or 7 acids that are very, very strong, and hydrochloric acid is one of them. When it bonds together, it forms a single bond to the chlorine. So why does it only form, whoa, my pen, 1 bond? Well, the Lewis or electron dot diagram shows you that. Sorry, I have pen problems. I have 1 bonding electron from each of them. And because I have 1 bonding electron, sorry guys, my pen, you guys know what it's like. Because I have 1 bonding electron in each of them, I remember on the last slide, somebody drew a heart. You could draw a heart here. They are attracted to each other. They will bond and form a single bond. Every element will be happier for doing that, and I'll explain why on the next slide. And that's how bonding works. So, I mean, one of the reasons why I say carbon has so many combinations is because carbon has 4 electrons. So carbon can form lots of bonds, whereas fluorine or chlorine or hydrogen only form 1. Carbon can form 4. Cool. Okay, I'm pretty much finished. I just want to explain to you where we're going for the next week, or next week's class. And that's it, really. So this chapter is kind of spread up into 2 parts. We're going to look at how are ions formed, and we're going to look at how are bonds formed. How do molecules take shape? And the first thing I'm going to look at is, where do ions come from? How come calcium is 2+? How come nitrogen is 3-? And it has to do with the octet rule. So you guys give me 3 or 4 more minutes and we're done. The octet rule. Octet means 8. If you think of an octopus, 8 tentacles. An octagon, if you watch like MMA, or I mean, you're familiar with polyhedrons, like mathematical shapes, 8 is octet. The rule is elements or atoms are not stable until they have 8 valence electrons, or basically their outer energy level is full. Reactions happen to make elements become more stable. So what happened with this reaction here is the fact that they bonded, it helped them become more stable. And we'll talk about that next week. Just a little note here, like I mentioned previously, noble gases are full. So they're not going to bond with or react with other chemicals. They're very stable. So we have this magic number of 8. And all I want to show you is 2 slides. I'm going to show you sodium. Each atom, and we're going to be talking mostly about main group. So very common elements like nitrogen, oxygen, sodium, calcium. We're not going to deal with things like tungsten or uranium. But each atom will gain or lose electrons until its valence shell or energy is full. Now, I have a question for you. I have sodium. Sodium is in group 1. It has 1 electron. What do you think sodium would, okay, if you were sodium, what would be easier? To lose 1 electron or to gain 7 electrons? What do you think is easier, to lose 1 or find 7? All right. Yeah. Okay. Same as my class this morning. Lose, 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 lose. Everybody's saying lose. All right. You are all correct. And I mean, you can think about money or even anything you're trying to give away or find. It's a lot easier to give away 1 thing than to pick up 7. Now, this is where the octet rule gets confusing. Because if sodium gives away that electron, some of you might look at that picture, the electron dot diagram, and you might say, well, now there's no electrons, so it's empty. That doesn't fit the octet rule. So what you need to do is go back to the electron configuration that we did in chapter 1. Remember, sodium is 1s2, 2s2, 2p6, and 3s1. Again, we did that like 2 weeks ago, so if you can't remember, you might want to do a little review of electron configuration. But what's happening is this 3s electron is going, it's leaving. So again, you might be looking at this and say, well, how does this satisfy the octet rule? Well, if we go back 1 energy level, it has 2 and 6. 2 plus 6 is 8. It's a little hard to visualize, but that's what's happening. When sodium loses 1 electron, that 3s goes away, and now we're left back in the 2nd full energy level. So here's the answer to that question. Basically, sodium will lose 1 electron, and that's exactly why this sodium ion is always Na+1. It loses an electron, so it has 10 electrons, 11 protons, plus 1. We did this in chapter 1. Okay, guys, it's a little early, but now you are on the same page as my class in the morning. My morning class, I don't know what happens, but I never get as far with them as I do with you guys. So I'm going to stop for now. I'll hit stop recording. And if you have any questions, let me know in the chat. And other than that, have a good weekend.